revolutionizing the way that you learn. Need math help? Well, come and have your turn. Stress-free learning.
If your thoughts do not motivate you, you are not thinking big enough. So dream big and go get them. Boom. Okay, we're about to get started. Today we'll be doing inverse graphs and logs. Right? We'll be doing inverse graphs and logs. Let's start with inverse graphs. What do inverse graphs mean? Inverse graph is basically saying we're swapping a graph about the line y is equal to x. So we are swapping the graph about the line y is equal to x. Let me write that down so that you can get exactly what I'm saying. Y is equal to x. We are swapping a graph about the line y is equal to x. Right? Keep that in your mind as I'm doing this. So let me do example 1. Right? Example 1 is y is equal to 2 plus 2x. That's my example. And then they say find the inverse of 2 plus 2x. Okay, so this graph here, this graph was just to show you this is swapping of inverse graph. So we want to find the inverse of this curve. How do we find the inverse of this curve? We reflected about the line y is equal to x. So it becomes that graph. So this graph would be g of x. So therefore, if this is g of x and that is the inverse, that becomes g inverse of x, which is g to the negative 1. Right? Keep in mind when you come across g prime, this is not the same as that. This is g inverse g to the power of negative 1 of the function x. Right? So now let's do the example. Example 1 says y is equal to 2 plus 2x. Find the inverse of this graph. So how do I find the inverse of a graph? Right? So if you're listening carefully to what I was saying a few seconds ago, I said it's the swapping or reflection of a graph about the line y is equal to x. What does that mean? It means that if I'm looking for the inverse of this graph, I must swap the y and the x value. That's it. That's what inverse means. Just swap the x and y value and let's see what happens. So if I swap the x and y value, it becomes 2 plus 2y. So wherever I see an x, I put a y. Wherever I see an x, I put a y. Wherever I see a y, I put an x. Right? So this is my graph. Is this it? I'm done. That's it. Right? No, I can't leave my graph in this format here. I have never seen a graph that's given in that format. So I have to write it in terms of y. Okay, so you might be asking why, but that's how you have to do it because they gave you the graph in terms of y. So we have to write your graph in terms of y. So what do we do? What's the first step? The first step is obviously to take the 2 onto the other side. So it becomes 2. And then become x minus 2 equals to 2y, right? That's what I have now. So now y is still not by itself. So what do? I have to divide both sides by 2. So if my equation becomes y is equal to x divided by 2 minus 2 over 2. Right? This is what it becomes because I divided by x by 2 and I divided by negative 2 divided by 2 and 2y divided by 2 becomes 1. Right? So this is equal to half of x minus y. That is my final equation and that is my graph. Right? But let's take notes of something. Right? Let's take notes of something. Y is equal to 2 plus 2x. Right? That can also be written as y is equal to f inverse of x. Sorry. Cut. This can also be written as f of x, right? Because this is a function of x, right? So we write it as f of x, right? So that means that our answer, I can write my answer as the terminology that is used for inverse is f inverse of x is equal to half x minus 1. This is how I should write my answer. My answer would be f to the negative 1 of x is equal to half x minus 1 because that is the inverse of my f of x graph, right? So that is basically it on example 1. Right? Now let's look at the domain and ranges of inverse graph. So the domain, let's start with the domain. Let's do an example so that you can see it in a practical way. So the domain, for example, let's say, before you write your paper, try to be relaxed and positive. Because if you are stressed out before you write your paper, you end up forgetting the things that you know, the simple things. So be relaxed and positive. These things are easy if you sleep early and you studied well. They gave me example 2. The domain of f is x is an element of negative infinity to positive infinity. Okay, so my question says, example 2 says, the domain of f, x is equal to, x is an element of negative infinity to positive infinity. And the range of f is, y is an element of 0 to positive infinity, right? That's my range and domain of the function f. Could be f of x, f of whatever. So this is function of f, right? So now I want to say, the question says, what is the domain and the range of f inverse of the same graph? So what is the inverse domain and range of the function f, right? So what are we saying? We're saying, what is the domain of f inverse, right? Remember, it's f to the negative 1, right? And then what is the range of f inverse, right? So these are the two things that we want. This is basically what the question is asking for. So how do I find that without knowing any graph, without looking at any picture? What I know is what did we say over here? We said the y and the x swap, right? That's how I got my inverse function, my inverse graph, my inverse line. So how do I do this here? I do this by doing the same thing if the domain is the x, because the domain deals with numbers in the horizontal line, which is in the x plane, and the range deals with numbers in the y plane. So if I swap my x and y in the above question, what does it mean about my domains? My domains have to swap. So the domain becomes a range, and the range becomes the domain. So basically what the answer would now then be is x is an element of 0 to infinity, and y is an element of negative infinity to positive infinity, because we swap the x and the y. So the graph is a little different now. It's the opposites, right? That's why the domain and the range would swap. So yeah, that is basically it on inverse graph. You come across a little bit more complex functions like my straight line, which I gave you, where you will need to use logs, right? So that is why we are going to be doing some logs. Okay, so my laws of logs. Okay, if you can look now, these are the laws of logs, right? There are 4 of them. The first law says that the log base b, which is b as you can see there, x multiplied by y. So let me make that a dot. Dot, right? Log of x times y is equal to, if you can separate them, it becomes log b of x plus log b of y, right? That's basically when you multiply the log inside a log, inside one sum of a log, right? Law 2, what does law 2 say? It says log b of x divided by y. What does it become? When you separate it, it becomes log b of x minus log b of y. As you can see, the difference between multiplication and division is a negative and a positive sign, right? The third law says log b of x to the power of n, right? This is an exponential log, right? So it's equal to n log b of x. So you take the exponent, you put it outside the log, and everything else stays the same, right? And make sure you take notes of this, because you'll be using it more often than you think, right? And then the fourth law that you barely ever use is log of b of x, right, is equal to, it becomes log of x divided by log of b, the base. Not small letter b, but capital B, right? And that is it on all of your log rules. So in my example 1 says, evaluate the log base 4 of 10 minus log base 4 of 22 plus log 4 of log base 4 of 33, right? So how do I evaluate this, right? How do I how do I find the answer of this? I use my rules which I have over here. So I want to evaluate this. By evaluate, I mean, how do I get it to one term or make it look like it's one thing? Let's say they say without the use of a calculator. Because if you had a calculator, you just put all of this in the calculator and see what it gives you. But without the use of a calculator, you have to think a little bit and use your rules. So what's the first step? The first step is, I don't want to do the subtraction one first. Why? It looks a little messy. So I want to do the addition one first. So what do? I rearrange this so that it's written like this. It'll be log base 4 of 10 plus log 4 of 33. So I bring what's the last one and I bring it closer to make it next to the plus. And then I say minus log 4 of 22. Yikes. I am running out of space. Appeared. Okay, so now this is what my log. So this is equal to, right? The next step, right? So now I have my pluses next to each other because that's the law I want to work with first, right? So log base 4 of 10 plus log 4 of the base 4 of 33. How do I combine that? I use the first law because that's what separates it into a plus. What separates it into a plus is they were multiplying each other. So what does it mean? It means this will be log base 4 of 10 times 33 minus log 4 of 22, right? So that's how I combine those. But take note, if my bases were not the same, I could not do this. So if my bases were 4, 5, and 6, I couldn't do it. If they say don't use a calculator, I'll be like, I don't know what to do from here, right? But since the bases are the same, you can combine them, right? So I combine the first one using the first law, right? Now I have a subtraction sign. So that means that I must refer to my second law, right? My second law says that we divide x divided by y becomes log x minus log y. So since I'm going backwards, what do? I will say the log of 4, because I know it's going to be one term. So I'll say log 4 and I'll open up my bracket, right? So what is x in this instance? X in this instant right now is 10 times 33 because that's the first one, right? So it'll be 10 and that's the positive one, right? Divided by the negative one. The one that's negative is the one in the second log, which becomes 22. So it'll be 10 times 33 divided by 22. And that's how I'll end up with, which is equal to, which I can simplify to log 4 of 330 divided by 22. And I have simplified this without the use of a calculator. And this is basically what they will need you to do. And they will not need you to solve this because there's no way you would know how to do log in your head. I could be wrong. But anyways, yeah, so this is where that's your final answer. You can leave it as is. Right? Okay, so now let's look at log functions, right? These are the ones we are saying you might have to use logs more often in log functions. How do you get to log functions? You have to come from an exponential function. Let's say you have an exponential function that says y is equal to 2 to the power of x. Y is equal to 2 to the power of x. That is my exponential function, right? And then they say find the inverse of this, right? They say they want the inverse of my exponential function. I'm like, what do you mean inverse? How do I get the inverse of this, right? But we follow the same steps. What are the steps? The first thing you need to do is you need to swap the x and the y value. So this becomes x and that becomes y. But I can't leave it like this. So this is where logs come into play. Because since I can't leave it like this, How do I take the y from the top to the bottom, right? How do I remove that exponent? I have to use logs. So I know if I use a log, the y will be at the bottom, right? Y is equal to, and then I bring my log, I put my log here, right? What's at the bottom? What's the first thing? First thing is there's a base. What is the base of this log? The base of this log is the base of the exponent, which is 2, right? And then in the bracket, I will have x. So my log function becomes y is equal to log 2 base 2 of x from my exponential function. So this is the I feel like you probably have heard this before, but this is a tip of all tips. You can pass matric by just doing past papers. Let that sink in. You can pass matric by just doing past papers. So look at the number of past papers that you're doing and times that by 10 and see how easy matric will be. The inverse, which is equal to f inverse of x. That is if this is f of x, right? So that is the inverse function of my exponential curve, my exponential graph, right? So now, let's, for example, one thing you should note about logs is if there is no base, if they just write log of x, right? It means that we assume that the base is 10. So remember that we assume that the base is 10 if they just give you log 5 or log 20 or log xy, right? We just assume that the base of that log is 10, right? So let's do an example. Let's do another example so that we can see. It says that, let's see, for example, example 1, right? So my example 1 says convert. My example 1 says convert this log into an exponential function, right? Log 4 base 4 of y is equal to x. How do I do that? How do I convert from log backwards now to exponential function? What I have to do is use the same rules but apply them backwards. How do I do that? I do that by saying, okay, so what's inside is going to be the exponent, right? You remember that? So how do I do this, right? I look at this and I say, what's on the inside will be what the graph, what it's equal to, right? And what's on that side would be the exponent, right? How do I know this? Because of my log rules, right? So I know my rules, so now I can apply them. So I know that it's going to be y is equal to, and the base of my exponent would be 4, right? And 4 is to the power of what? What's on the other side, which is the x, which is why it's 4 to the power of x, which is the exponential function of that log function. That's how I turn that log function into an exponential function, right? So now let me look at example 2. My example 2 says that solve for x, right? Normally this might work. This might be like, for example, when you have to look for the x-intercepts or the y-intercepts. That's when you might have to solve for x. But in my example, I just want to say solve for x so that you understand the concept of logs, right? So where do I start? I start by saying, okay, what do I want to do? I want to get x to be at the bottom, right? But I need x to be by itself. I need that whole thing to be by itself. So what do I do first? I divide both sides by what? By 5. If I divide both sides by 5, I end up with 5 on this side, and 5 divided by 5 is 1. 5 divided by 25 is 5. And I'm left with 1.05 to the power of x minus 1. Right? That's what I have now. Right? So now, where do I go from here? Now I'm stuck. What do? I'm used to having only x at the top. So what can I do? I must give up, right? I must leave these marks on the table because I don't need them. I don't need matric, right? No, this is easy. Use your logs. It's the same thing. So what do? We take this whole thing in the exponent as one bracket. We consider it as one bracket. So what does that mean? So we know that it's going to be x minus 1 is equal to. Why? Because we always drop what's in the exponent like this to the other side. What's in the exponent all the way onto the other side by itself, right? Since we consider the whole thing as a bracket, we bring the whole thing right? Since we brought the whole thing, it's x minus 1, right? Is equal to. So we write our log. So it'll be log. What is the base of our log? The base of our log is the same base as the base of the exponent. The exponent's base was 1.05. So the base of our log would be 1.05. And what is in our big bracket? Our big bracket will consist of what was on the other side of the equation, which was 5. And that is the difficult part. We have done the most difficult part of this equation, of this question. And since we have done that part, so now we can just cruise. Don't miss marks once you get here. Because there is no good reason why you'll be missing marks for calculator work. This is calculator work. So how do I get x by itself? I take the 1 onto the other side. So what does that mean? I add 1 on both sides. So x would be equal to the log of 1.05, our base 1.05, of 5 plus 1. Because I took the 1 onto the other side. The value of this gives me 33.99, right? My answer for x is 33.99, right? If you want to check that I'm not telling you some nonsense, put it in your calculator. Put that value over there, the x is equal to 3.99, and see if it gives you a value that's very close or exactly close to 25. If you put the exact value of the log, you'll get an exact value of 25. But if you put 33.99, you might get like a 24.48 or 24.5 something or 6 something. But something very close to 25 because you round it off, right? So this is basically it on logs. This is how the different places that you can apply your logs, and that's how you end up with having log functions. And you have to know how to convert them to exponential functions and vice versa, meaning that you also have to know how to convert from exponential functions, right, to logs. So that's basically it on log functions and all of your inverse graphs and logs. Okay? Boom! Go check out the next video.